Today's video is going to talk about data distribution, and this is going to allow us to see what all those values we've learned to calculate really mean in the real world. The first thing that we want to talk about is what is data distribution. And this is the way that data values are clustered. So this first picture is an example of positively skewed data. The second one is a picture of negatively, well, if I could spell. There we go, negatively skewed data. And then the last picture is of a normal distribution. And we put normal in quotes because this has a definition. It's not just saying like, oh, this is the normal way, this is the regular way. This is actually a very specific distribution, and it is called a normal distribution. So normal distribution is a symmetrical bell-shaped curve defined by the mean, mu, and the standard deviation, sigma, of the data set. The area under the curve represents the probability with the total area equal to 1. So let's look at this a little bit more. There's something called the empirical rule, and it only works with normal distribution. So if we have a normal distribution and we know the mean and we know the standard deviation, we can find out all kinds of things about a set of data. So the empirical rule tells us that approximately 68.2% of the data falls within one standard deviation of the mean, and approximately 95.4% of the data will fall within 2 standard deviations of the mean. And finally, 99.8% of the data should fall within 3 standard deviations of the mean. So I want us to fill this in. What that means, it says, the first part says 68.2% of the data falls within 1 standard deviation of the mean. So that is this section of the graph right here. So if these 2 sections make up 68.2%, then each section in the middle must make up 34.1% of the data. Then it says that 95.4% of the data, so from here to here, lies within 2 standard deviations of the mean. So we know that we already have 68.2% right here. So if we subtract 68.2%, we're left with 27.2%. And that 27.2% is in this one and this one. So if we divide that by 2, we get that each of these contains 13.6% of the data. And finally, within 3 standard deviations, so this section of the graph, that is where 99.8% of the data is. Now, if we take that 99.8% and subtract the 95.4% that we've already allotted, that will give us 4.4% left to divide between this section and this section. So when we divide 4.4 by 2, we get 2.2% here and 2.2% here. And last but not least are these outer edges that are everything past 3 standard deviations. And if 99.8% of the data is in those first 3 standard deviations in these 6 sections, then that only leaves 0.1% for each side or each end of the graph. So let's walk through an example together. This says to draw and label normal distribution curves, then answer the questions. There's actually not anything to draw because it's given us the drawing already. So That was nice of them. But what this tells us, the weights of the 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8 pounds. So if you remember from our picture that we just looked at, the mean is the middle value. Let's actually go back and take a look. So I didn't really mention this whenever we looked at it initially, but if you notice, this is the mean, this is the average value. So that's the center of the data. And then each of these dotted lines, this represents one standard deviation above the mean, and this is one standard deviation below the mean. So all this data in here is within one standard deviation of the mean. It's no less. It's not more than one standard deviation above or below. And then this section includes 2 standard deviations from the mean and then 3 standard deviations from the mean. So going back to our example here, it tells us that the mean is 178 pounds. So that means that this center line represents 178 pounds. And then if each line is a standard deviation away from the mean, and the standard deviation is 8 pounds, then if we add 8 pounds to 178, we should get the next mark, the next value of our dotted line. And then we will add 8 pounds again, and one more time. Then we're going to subtract 8 pounds so that we can get the numbers on the left. Subtract 8 again, and one more time. So these are what each of these lines represents, the value that they represent. And we want to go through and label the percentages as well so that we don't forget what those are. So the first section is 0.1%. The second one is 2.2%. The third one is 13.6%. And finally we have 34.1%. And those mirror each other on the other side. So now let's talk about these questions. What percent of the players weigh between 178 and 194 pounds? So 178 is this line right here. 194 is this line right here. We want to know what percent of the players are between these two marks. Well, the percentage of players is what these numbers represent. So if we just add 34.1 plus 13.6, we're going to get 47.7% of the players weigh between 178 and 194 pounds. Part B says, what is the probability that a player weighs at most 170 pounds? So at most means they must weigh less than that. So here's 170 pounds. We're looking at all the data that is less than that value. So we want to add up the 0.1% plus the 2.2% plus the 13.6%. That's going to give us 15.9% of the players, sorry, it's not percent of players, it kind of is, but this is the probability that a player weighs at most 170 pounds. The probability is 15.9%. Part C says, what is the probability that a player weighs less than 162 pounds or greater than 194 pounds? So 162 pounds is right here, and less than that would be these two sections. So we know that we're going to have 0.1 plus 2.2. But we also want to include greater than 194 pounds. So that value, 194, is right here. So that's going to include these two sections. So we're going to add 2.2 and 0.1 for those other two sections. We're going to find that this is going to equal 4.6%. So the probability that a player weighs less than 162 pounds or greater than 194 pounds is 4.6%. Now this question asks us how many players. That is different than what we've been talking about. how many players weigh between 170 and 186 pounds? So 170 is here, 186 is here, and it wants to know about how many players are between those two. So if we look at these percentages, 34.1 and 34.1, let's start by adding those together. And we're going to see that 68.2% of players are between these values. We know that a percent written as a decimal is 0.682. And if we multiply that by how many total players there are, so there are 50 football players, that's going to tell us about how many players weigh between these two numbers. So multiply that times 50 football players. That gives us 34.1. So we're going to say about 34 players. That is all for today's video. Thank you guys for watching, and I hope you have a great day.